Okay, welcome back, ladies and gentlemen. We are on the back page here, number 4, and we'll keep things rolling. So, determine the number of roots in the following functions, then find all the possible zeros of the function. There are 3 possible roots. Okay, so 3 possible roots. Max, let's take a look here. So I'm going to my calculator. I'm going to type in y equals x to the third minus 3x squared plus 12x minus 10. Okay. And if I hit graph, see where it hits. We are hitting at positive 1, so I know 1 will be a good one to use. 1, negative 3, 12, negative 10. We're just doing synthetic division, which we're going to get very good at. Let's see here, negative 2, 10, 10, 0. Okay, so taking a look, I have x minus 1. Remember, it's the opposite there. X squared minus 2x plus 10. Right? Now, for this particular problem, okay, you'll try as hard as you might, you're not going to find anything here that's going to factor. There's no numbers that multiply give you 10 but add to negative 2. So the first one's easy. But here, if I set this equal to 0, I have to use good old quadratic formula. Okay, isn't that bad. Negative 2 is positive 2, plus or minus square root b squared minus 4ac divided by 2. I'm sorry, the little thing's in the way here. Out of your way. I'm going to go up just to make it a little bit easier on myself. 2 plus or minus. Negative 2 squared is 4, minus 40 is negative 36. So then I've got, that's equals 2 plus or minus 6i over 2. Everything's divisible by 2. 1 plus or minus 3i. Okay? So there's an example of an imaginary root again. So there's my 3 answers. The 1 plus or minus 3i, which are 2 answers, and then the 1. Alright? Very good. Okay, we just have 3 last little problems here to work on. They're going to increase in difficulty as we go. So let's start with the easy one and then work our way up. Find a polynomial equation with the lowest degree possible that contains the given roots. What you are doing here is basically making your own problem. If your answers are x equals 2, x equals 3, and x equals negative 1, I'm going to write them as binomials. X minus 2, x minus 3, and x plus 1. Okay? So now what I'm going to do here is FOIL. Right? It's pretty fairly simple. All you are doing is you're creating a problem. You're working backwards. So I'm going to FOIL this out. Now, just to make my life easier, I'm going to FOIL the first 2. X times x is x squared. X times negative 3 is negative 3x. Negative 2x. If I combine them together, I get minus 5x. And then negative 2 times negative 3 is positive 6. Okay? I'd bring down my x plus 1. And all I'm going to do is multiply one more time. So, f of x equals, we got here x cubed minus 5x squared plus 6x. When I multiply the x across, multiply the 1 across, x squared minus 5x plus 6. Combine like terms. Negative 5x squared plus x squared is minus 4x squared. 6x minus 5x is plus x. And then plus 6 at the end. Now here's the cool thing. If I have y equals, or I have my calculator right here, if I type in my answer, minus 4x squared plus x plus 6. If I graph this, I'll know I did this right if it hits at negative 1, positive 2, positive 3. There you go. This is actually how I create problems for your tests. Okay. All right, now, part 6, or number 6. 2dr. dr stands for double root. So when I do my x minus 2, since it's double root, we just do 2 of them. Okay, nothing too crazy. And then here's the thing about negative 3i. they always have to come in pairs. So if I do the opposite, I get x plus 3i, and the next one would be x minus 3i. They always come in pairs. Always come in pairs. Right? The first, let's take a look here. Let's do the first two together. I get x squared minus 2x, which is minus 4x, plus 4. And then over here, if I multiply these out, check out what happens. X times x is x squared. X times negative 3i is negative 3xi plus 3xi. They cancel out. And then 3i times negative 3i is minus 9i squared. Okay? Cool. Well, what's I squared equal to? Negative 1? Yeah. So this ends up becoming x squared plus 9, which makes sense if you think about like how you would solve it. And all we're doing is back to the drawing board, multiply this across, multiply this across. F of x equals, let's see here, x to the 4th minus 4x to the 3rd plus 4x squared. I multiply the 9 across, plus 9x squared minus 36x plus 36. And then combine like terms. That's the only x to the 3rd I have there. 4x squared plus 9x squared is 13x squared minus 36x plus 36. And we're all set. These ones are a little tougher because if I graph that, you can't really see the imaginary roots on a graph, but you get the idea. Okay, the last one, the doozy one. I promise we will get some practice with this, but please just bear along with me. I'll work through it and copy it down. But when it says plus or minus root 2, so if I jot this out, I've got x plus root 2, x minus root 2. There's my starting point. Simple enough. Now, for this, what I'm going to do is we go x minus, okay, this thing right here, 1 plus 2i. Okay, there should be 2 parentheses here. And then I'm going to do x minus the same thing. I'm going to change the plus 2i to a minus 2i. Okay? Now, next line down, I'm going to go ahead and multiply these out first. Let's cover this up. X times x is x squared. X times negative root 2 is negative root 2x. Plus root 2x, they cancel out. Positive root 2 times negative root 2 is minus square root of 4, which is 2. So that works out kind of nice. Okay. Now over here, we have to do a little trick first. What we're going to do is, you can distribute this minus sign across. So you get x minus 1 minus 2i. Same thing over here. X minus 1 plus 2i. And what we're going to do next is a little trick that makes your life way easier. Can you see how I have the x minus 1, same for both of them? We're going to throw an extra pair of parentheses around it. Okay? Watch what happens next. The x squared minus 2 stays the same. When I FOIL this, x minus 1 times x minus 1 is x minus 1 squared. X minus 1 times 2i is plus 2i x minus 1. And the inside, negative 2i times x minus 1 is minus 2i x minus 1. And finally, negative 2i times positive 2i is minus 4i squared. Look what happens in the middle. These cancel out. Okay? So I'm left with x squared minus 2, x minus 1 squared, minus 4i squared becomes plus 4. Alright? I have to square this out. Just a little bit of side work. I'm going to do it over here. X minus 1 times x minus 1. Alright? So we get x squared minus 2x plus 1 and then plus 4, which, if I look inside here, 1 and 4 is 5. kind of cool. And finally, after all that, we just do one last little round of multiplying across. I'll bring it over here. Let's see, x to the fourth minus 2x to the third plus 5x squared minus 2x squared plus 4x minus 10. And combine last like terms. Okay, there we go. So I know that problem's a doozy. That one's especially a little tough. We will get some practice with it. Please don't think that you need to be experts at it right away. But I will get back to this problem. Okay, I'm hoping that these two right here made a little more sense to you, and that's good. It's a good foundation. We'll roll from there. Please keep working with your graphing calculators. If you are needing any help with them whatsoever, just say the word. But yeah, so we have a little bit of practice to work on now, and we should be in good shape. And as always, keep up the good work. We are all counting on you.